Hello, this is Mrs. Poland for midterm review in AP Statistics, and in this section I'm going to go over some of the problems from Chapter 3. So let's start off with number 15. Use the following computer output for a least squared regression. And so it's really important for you to learn to read the table. So next to the constant is your y-intercept, and next to the x is your slope of the line. In many cases, they'll define what x is, and that's your explanatory variable. The S represents the standard deviation of the residuals. R squared is the coefficient of determination, and you can ignore R squared adjusted. Remember, when you're writing the equation for least squared regression line, your y has to have a hat over it. That indicates it's a predicted value. So y is equal to a plus bx. So in this case, it would be 22.94. The slope is negative 0.6442. And then x, again, if you're given a variable name, you should really be using that. And when you look at the choices, that's choice D. One thing that they didn't ask, but they could ask, is what is the correlation coefficient? And you can get that by taking the square root of the coefficient of determination. So you would first place that into 0.148, and it's plus or minus when you're taking the square root of something. And so I'm just going to enter that in the calculator. And when I do that, I get plus or minus 0.3847. So how do we know which one the correlation coefficient is it? Is it the positive value or negative value? Well, in this case, we know it's the negative value. How do I know that? Because the slope of the line is negative, and the slope and the correlation coefficient will have the same sign. So even though they didn't ask for it, I thought this would be very valuable information for you. Number 16, a copy machine dealer has data on the number X of copy machines at 89 customer locations and the number of Y service calls in a month at each location. Summary calculations give that the mean is 8.4, the standard deviation is 2.1, the mean of the y values is 14.2, and the standard deviation is 3.8, and the correlation coefficient is 0.86. What is the slope of the line of the least squared regression line of the number of service calls based on the number of copiers? Okay, so the service calls are our y, and our x is the number of machines, so that's x. So this actually is a formula on the reference sheet, so make sure, like, you should be always having that reference sheet out in front of you anytime you're doing your homework. It's a mistake not to, because you're trying to train yourself. The better you study for this now, the easier it will be the second half of the year. So they give you all the information. They gave you that the correlation coefficient is 0.8. They gave you that the standard deviation is 3.8 and 14.2. Just be careful. Like in this case, they clearly define X and Y. Sometimes you have to read the problem more closely. And when we enter this into the calculator, we get 1.56, which is choice B. Number 17, this is based on problem number 16, the one that we just did, about what percent of the variation in the number of service calls is explained by the linear relationship between the number of service calls and number of machines. Well, that is the definition. Like, if you look at this wording, that's one of those sentence frames that you must memorize for this exam as well as for the AP exam. So you may want to use those cards that I got you, or look at the chapter 3 lessons on the coefficient of determination. That is r squared in in the context of the problem. So in this case, r was 0.86. So you would just have to square it, and that is 73.96. So you have to know your definitions. Number 18, the equation of a least square regression lines for the points on the scatter plot is shown below, or actually to the side. So this is the equation of the least squared regression line. And they're looking for the residual. And they give you an actual value, x, y. So let me make my y a little here so it doesn't cover up the number. There's no abbreviation for residual, so some of you were getting confused between the r's. There's no abbreviation. You have to write the word residual. And the formula for it is y minus y hat, the actual minus the predicted. So to do this problem, we know y. It's 7. They gave it to us, correct? We need to calculate the predicted y, and we do so by using the equation, and you're going to substitute 10 in for x. And when you do that, you get 8.6. So the residual is 7, that's the y, minus 8.6, which is negative 1.6, and that's choice C. When you have a negative residual, that means that the least square regression line overestimated the actual value, so this was an overestimate. If it was a positive value, then the least squared regression line underestimated the actual value. Number 19, suppose the correlation between two variables is 0.23. What will the new correlation be if 0.14 is added to the x variable and every value of the y value is doubled and the two variables are interchanged? Well, if you look at the formula for the correlation coefficient and they give it to you, you actually don't need to memorize this, but sometimes the formula is helpful to see, and it's on the formula sheet. This kind of looks like the z-score for your x variable and the z-score for your y variable, because it is, and they're summing those for each point, and then they're dividing it by the sample size minus 1. So the key thing is if you're changing your data, if you're adding x things to all of your x values and you're multiplying it, it's having no effect because you're standardizing those scores. Also, since multiplication is commutative, switching your x and y has no effect on the correlation coefficient. However, it would have an effect on the slope of the line. And so the correlation coefficient would stay the same. So it's A. Number 20, each of 100 lab rats has available both plain water and a mixture of water and caffeine in the cages. After 24 hours, 2 measures are recorded for each rat. The amount of caffeine the rat consumed, that's X, and the rat's blood pressure. The correlation between X and Y is 0.428. Which of the following conclusions is justified based on this study? A, the correlation between X and Y and the population of the rat is also 0.428. That's incorrect. We have no idea what the correlation coefficient is based on the population. We can only determine it based on the sample. If the rat stopped drinking water, the water caffeine mix, this will cause a reduction in their blood pressure. There's a couple of reasons why this is incorrect. The first is when you're doing this kind, you would expect, I guess the key thing is First of all, it's not causing that to happen. Um, you're looking at the correlation, which only shows the strength and direction. And so this would have no impact. You can't establish that cause and effect. So that's not it. Now let's look at choice C. About 18% of the variation in blood pressure, here we go again, can be explained by the linear relationship between blood pressure and caffeine consumed. Does that sound familiar? Well, it should, because it's similar to 17, right? That same type of wording. And that's, again, you need to know the interpretation for the coefficient of determination. The coefficient of determination talks about how the actual points vary from the least squared regression line. And the closer you are to 100%, the better the fit of the line, the more points that are close to the line of best fit. And the other choices, again, don't really make sense in the context of the problem, and they're just distractor choices. So the answer is choice C. 21. Which of the following statements is or are true? Scatter plots require that both variables be quantitative. That is definitely a true statement. You can have a categorical and a quantitative. They both must be quantitative. So the x and y both have to be quantitative. Switching the explanatory and response variable will not change the least square regression line. That's false. They're trying to trick you. They're trying to make you think of the correlation coefficient, because that doesn't change. But think about it. The slope of the line is defined as r times sy over sx. That's the formula you would use. If you switched your x and y value, your standard deviations would be flipped. And the only time you would end up with the same slope, okay, would be if sy and sx reduced to 1. They were the same value. And so, switching the x and y affects the slope of the line. And so that's a false statement. Every least square regression line passes through x bar, y bar, and that's a fact that you need to know. When they calculate the least square regression line, the line must pass through x bar and y bar. And so our final answer, so this is true. I wrote down the wrong thing. Sorry about that. So 1 and 3 is the answer, or B. I'll just go through a couple more. I'll go through 24. I guess I'm going through all of them again. Okay. All but one of the statement contains a mistake. Which one could be true? The correlation between gender and age is negative 0.171. This is false, and the reason it's false is gender is a categorical variable. It's not quantitative. B, the correlation between weight and length of the foot is 0.488. I think that's the answer because I don't see weight and length of the foot are both quantitative. 0.488 is a valid correlation coefficient. So I think this is true, but let's go through the rest of the choices. If the correlation between blood alcohol level and reaction time is 0.73, then the correlation between reaction time and blood alcohol level is negative 0.73. So what they were trying to do is test your knowledge of what happens if you switch your x and y variable, x being the alcohol and y being the reaction time in the beginning, and then switching it. Well, we know that it has no effect and it should be 0.73, so that's a false answer. The correlation between breed of dog and weight is 0.435. The reason why that's wrong is breed is a categorical variable, not quantitative. The correlation between height and weight is 0.568. And the reason why that's wrong is the correlation coefficient R is unitless. It's just a ratio. And so that is incorrect. And so B is the answer. Number 23, a biologist is interested in predicting the percentage increase in lung volume when inhaling Y, so this is our Y variable, for a certain species of birds from the percentage of carbon dioxide in the atmosphere. That's our X variable, or explanatory variable. Data collected from a random sample of 20 birds of the species were used to create a least square regression line. So they gave you an equation. Which of the following best interprets the meaning of the slope of the least square regression line? Well, first of all, what is the slope of the line? That's the negative 0.08. So you first have to identify that. And so we see it's negative, so there's a decrease. So that means as your X variable increases, your Y variable is decreasing. And what I'd like to do is I'd like to write it over 1. And so the numerator is the change of your Y variable, and the denominator is the change in your X variable. Well, what is our Y variable? Our Y variable is our predicted lung capacity, or lung volume, or the bird's lung volume, over the X variable is the percentage of carbon dioxide, okay, CO2. And so what this is saying, and again, there's that sentence frame. You should be looking at those definition cards. You do need to know your definitions. And basically what you're saying is for each additional blank, the predicted, whatever the Y variable is, it's going to be increases or decreases. In this case, it's definitely decreasing by about, and whatever the slope is. And so in this case, for each additional percentage increase of CO2, the predicted lung volume decreases by about 8.02. And then you have to carefully go through the choices because it could be confusing. You have to be careful with the wording. Choice A, the percentage increase in lung volume. Well, lung volume is not increasing, it's decreasing. So A cannot be the choice. The percentage of carbon dioxide in the atmosphere increases by 8%. It's not the carbon dioxide, that's the X variable. It's the lung volume that's increasing, or decreasing rather. The percentage increase in lung volume when inhaling decreases by about 8% on average for every 1% increase in carbon dioxide. This, I suspect, is the correct answer. It's just the wording is a little confusing because they first talk about the percentage increase and then they talk about the decrease. So let's just go through the choices to make sure that that's the best selection. The percentage of carbon dioxide in the atmosphere increases by 8%. No, because that's the X variable. Approximately 8% of the variability of percentage increase in lung volume when inhaling is explained by the linear relationship with percentage of carbon dioxide in the atmosphere. So what they did is they gave you the correct interpretation of actually, they didn't even give you the correct interpretation of the coefficient of determination, but they tried to trick you because they gave the interpretation. Mike, I'm videoing. 24. The computer output below shows the results of a linear regression analysis for predicting concentration of zinc. So you're predicting zinc, so that's going to be our Y hat, from the concentration of lead. That's our X. Found in fish from a certain river. Which of the following statements is the correct interpretation of 19 in the output? So this is computer output. Remember, next to the word constant is our Y-intercept, that's 16 zero point 0.3, and the slope of the line is 19. That lead, that's our x. And so basically, again, we're looking to interpret our slope. So our slope of the line is 19, and I'm going to write that as 19 over 1. So that's our change of y over change of x. Our y is representing the change in zinc, Zn, in parts per million, over our change in lead, Pb is lead. And so what we're saying is, again, we could do that same thing for each additional 1 ppm of lead, the predicted zinc, or the predicted concentration of zinc, increases by 19 ppm. And so when you look through the choices, what's wrong with the first choice? On average, there is a predicted increase of 19 ppm in lead. Well, that's our X, right? The lead is our X. We want zinc. So now let's look at B. On average, there is a predicted increase of 19 ppm of concentration of zinc, that's our Y, for every increase of 1 parts per million of concentration in lead. So I think that's the answer, but we should go through the other choice. The predicted concentration of zinc is 19 ppm with no concentration, in fish with no concentration of lead. They're trying to confuse you. That would be, they're trying to make you think of the y-intercept, and that's the same thing with choice D. And notice again, let's look at E. Approximately 19% of variability in zinc concentration is predicted by its linear relationship with lead concentration. So they're trying to get you confused with the coefficient of determination. To correct that, if that were the case, this would be 82%. I hope these videos are helpful to you, and I will see you tomorrow.